Alright, in circle O, arc AB subtends angle theta. Kelly must find the area of a sector of a circle enclosed by theta. She knows that theta is equal to 5 pi ninths radians and that the length of the radius is 20 feet. A, what steps should she take to correctly solve this problem? B, what is the area of the sector of the circle enclosed? So again, this is giving it in radians. So this is the formula that would be used. So I'm going to be looking for that. Because Kelly is interested in the portion of a circle whose central angle is theta, and because the measure of the whole circle is 2 pi radians. So I'm going to pause and ask myself, is that true? Yes, that is true. The measure of a whole circle around is 2 pi radians. Again, remember that radians is just another measuring system for like degrees. So we have 360 degrees in a circle, we have 2 pi radians. Just like in feet versus metric, it's just a different system to measure something with. So she can set up the formula as follows: area divided by 2 pi times pi r squared equals theta. To solve for the area of the sector of area A, she can substitute the known radians 5 pi ninths for theta and the radius of 20 for r. So I'm looking at this and I'm noticing that the only difference, if I'm scanning through this, is the difference in this is that the A is being divided by the 2 pi and it's equal to theta, and in here the theta, which is the degrees, divided by 2 pi is equal to the A. So I'm going to ask myself, well, what is theta representing? And theta is representing the angle, and just using my knowledge of, because I feel more comfortable with the degrees, I know that we take the degrees divided by the 360 that's in the total of a circle. So it would follow suit logically that we would still take the angle and divide it by 2 pi, since now 2 pi is since radians is now the measuring system. So we would still want our angle divided by 2 pi because 2 pi is in radians, which is the measure of a whole circle. So that's A. Now they set up the entire equation for us, so we can simplify this, and I actually like this one because it's actually simplified all the way, so it's not taking us back to ground zero. However, we'll just use the one that's given in this example. So we have area is equal to theta divided by 2 pi times pi r squared, which is the area of the circle. So now we know that theta was 5 pi ninths. 5 pi ninths. We know that our radius was 20. So we're going to look at this. I really dislike working with this in this format, so I'm going to change it. So we can always change the way that it's structured as long as we maintain what is happening. So we actually have 5 pi ninths being divided by 2 pi. So I'm going to remember this. Maybe this will jolt your memory. How we divide fractions is we copy the first one, we change it to multiplication, and we multiply by the reciprocal. So a lot of people call it copy dot flip. I call it multiply by the reciprocal because that is the mathematical term. So 5 pi ninths multiplied by the reciprocal, which would be 1 divided by 2 pi. Some of you might be saying, oh, where did the 1 come from? Well, any whole number can be written as a fraction over 1. So when you make a reciprocal, you just flip the fraction on its head. So then it'd be 1 divided by 2 pi. We're going to keep rolling with this. 5 pi times 1 is equal to 5 pi. And 9 times 2 pi is equal to 18 pi. How I did that is I just multiplied 9 times 2, which is 18, and I kept the pi. So now we have pi divided by pi, which reduces down to 1, so this is actually just 5/18 right there. So we dealt with this portion right here. So let's rewrite this down here. And we have the area is now equal to 5/18 because we simplified this all out, times pi times 20 squared. Okay, so now we can call it in the calculator, and I'm going to treat pi like it's not there because I noticed in the answers they still have pi there, so that means we're just dealing with the numbers. So I'm going to do 5/18 times 20 squared, and again that's this x to the y button, which is 111 and that doesn't match either of those, so let's go back and rework this. So what is 20 squared? It's 400. So this again could be rewritten as 400. Remember that's being multiplied. Again, we can multiply all of the numerators together. So this would be 5 times pi times 400, or I could say 5 times 400 times pi, because you can rearrange the order in which numbers are multiplied. So I just multiplied that all to the numerator, and again the denominator for pi is 1, so 1 times 18 is 18, and again the denominator for 400 is 1, so 1 times 18 is just 18. So let's try this. What's 5 times 400? That's 2,000. So 2,000 divided by 18. They both have a factor of 2 in it. So this is right here. This is 2,000. So I'm going to rewrite 2,000 as 2 times 1,000, and I'm going to rewrite 18 as 2 times 9, and reduce out this factor of 2 because 2 divided by 2 is just 1. So then I am just left with 1,000 times pi in the numerator and 9 in the denominator, and that did look like one of the answers. So we had 1,000 pi ninths, and that's how we would go about handling that.